Well, hello there. I'm Tom. Welcome to my first attempt at making a real YouTube video. Today, we're going to be trying to fix a lawnmower that was struck by lightning.
Watts of electricity. 21 gigawatts!
That little guy, right in the bed of the truck. Let's see if we can do it. Welcome to Tom's Cooking Show. On today's menu, potted PCB. So here's a little background information. I moved down from New York to South Carolina years ago, and it gets way too damn hot to mow the lawn. That's what I have this guy for. Robot lawnmower. But the situation is, it has to travel across the driveway and reach the other side. As you can see, that's an issue with cars. So as of now, it travels across between these two wires when cars aren't here, or it gets jammed underneath a car, over to this side of the lawn. So I picked up this lawnmower, real cheap, and I'm going to try to fix it. Welcome to my pool table, or for the purposes of this video, a recording studio. This is a Husqvarna 115H robot lawnmower. So what I've got with it here is this little extension, the power converter, and the charge station. Now the guy said that it was struck by lightning. Now I don't know if that means that his home was struck by lightning, if the mower was struck by lightning, or what the situation is. So we're going to try it for the first time, plugging it in, and seeing if it lights on fire. Voiceover Tom here. What you're watching is about 20 minutes of me voltage testing the power supply that came with it and the charging station itself. I went to the backyard and I got the power supply from my existing lawnmower since it's the same one, and we're about to see when I realize that it's not only the power supply but it's also the charging station that's fried. Enjoy. 1.6 volts. So that's likely just a capacitor in there discharging. So this is kind of our worst case scenario here. And I wonder how much these cost. Now if this weren't potted in resin, we could actually take a look at the board. But it is, so we can't. Me again. This is the point where I refuse to believe that both the power supply and the charging station are burned, and that I start testing it over and over again, hoping for a different result. I go into the backyard and I take the power supply that I received and I plug it into the charging station in the backyard, and it's indeed fried. So both of these components are destroyed, and eventually I just go to brute force and decide that I am getting into this thing and I'm going to take it apart. So I can't take it out. Of course, when working on electronics, I always have a crowbar. So here we go. Just a little generic circuit board. So what you do is you have this case here, you put the board in, and you just pour resin around it, which is essentially like an epoxy or a glue or what have you. And it completely seals it up so when it's outside, if it gets rained on or anything like that, no water can penetrate. But whereas with this guy, if something were blown, I could be coming through here, testing this resistor, etc. Checking the little 0 ohm resistors, which are fuses. This I can't. So this guy, I'm not too worried about, because again, we can get a generic 28 volt, that says 1.3 amp. Yeah, so generic 28 volt, 1.3 amp charger. Seal it up the best we can ourselves. Remove this end, solder it on, make it all nice. This guy though is going to have some sort of a dedicated circuit in it. Question is, how important is it? One workaround, since the mower out back is putting out 28 volts here, and this inverter is supposed to be putting out 28 volts, technically, you could charge it by just running the power directly to these terminals. However, we don't know where the battery control module is. If the battery control module is in fact in the lawnmower, then that would be fine. You wouldn't have any charging indicator, and you wouldn't have any antenna for it to know to go home correctly, but it would charge up the mower. Now if the battery control module is in here, and all the safety features of charging lithium-ion batteries are in here, which they most likely are, then you run into a problem. So as of now, I think the next step is, because we're definitely going to need this guy, see how much one of these costs, see if I could find a used one, and also take the actual mower, move that out of the way. This guy, which appears to be in good shape, plug it into my base station in the backyard and see if this will charge up. Since we have two fried components, I'm really hoping this guy wasn't charging when we got struck by lightning. Let's see. So what I have just learned is that apparently you can heat up epoxy resin that's been potted for an electrical circuit or PCB board to a little over, I believe it was 220 degrees, and it should turn into a Play-Doh type of consistency. Hopefully this will allow us to peel it off the circuit board, and we're going to actually have a close look at what blew on the board itself. Now, you're not supposed to put electronics in water. Everybody knows that, everybody hears that, but that's while it's running, so it doesn't short out a component. Alright, so now that my resin potted circuit board is cooked to a perfect medium rare, I'm going to try to see if I can chisel all this off. Okay, so as careful as I'm doing this, we have destroyed a coil on the board. I'm not sure if it's me that destroyed it, the heat from boiling that destroyed it, or if it blew up during the electrocution portion. Anyway, I'm going to carry on. And right here, no matter how careful I'm being, we just took a resistor off the board. So, if you can't tell by now, this isn't going very well. That's how small it is. So here's the verdict on that. I've been chiseling away at this thing, and I just tore another capacitor off the board here. The reality of the situation is, even if I can get this off enough to start testing components, it is just so caked on there that it's going to be stuck everywhere. I am not going to be able to get all of this off without completely damaging the board. I already killed 1, 2, and 3 components. So this isn't going to be feasible. We're giving up on that. However, we're going to think outside the box. So here's the game plan. To get all of that epoxy resin off of the circuit board inside for the new mower, I would have to have a lot more patience than I do, or have an act of God to help me out. So the new plan is, we're going to charge up the new mower on the old mower's station. What I'm going to do is I'm going to connect the boundary wire from the backyard to the side yard. Now what that's going to do, it's going to allow me to hopefully use both mowers on the one charging station, and I can still run the mower in the side yard. Now you're watching the ever so exciting task of splicing wires and isolating the boundary wire on the left side of the house from the one on the right side of the house. Now the biggest pain in the ass about having robot mowers is that guy who digs up the wire. It makes nice little holes for it to bottom out in. Don't you dummy. Oh, nice. Found my ring from when I was working on the lawn the other day. Alright, so here's our current status. As you know by now, I wasn't able to get all the resin off of that circuit board. But I was able to program the new mower to the old mower's base station, so they can both run and operate off of this base station and use the same boundary wire like they're twins. That being said, I can't fix the old charging supply for that guy, but what's to say that I can't piggyback this base station, the new base station, off of this charging base. Now bear with me. The physical connections, the two power connections, are still on that old base station. Even if I don't have that circuit board, what if I just jumper wire the two charging power, the positive and negative from this base station, run a wire, 2 wires technically, to the side yard into the back of the other base station. Now here's the thing, if they're charging at the same time, it'll take a lot longer to charge. Oh, this guy's trying to go home and... Oh. Sorry. Hang on a second. Chill, buddy. Yes, get out of my home. But in theory, I would be able to just run that base station off of this base station by running a wire to the side yard. I think that's possible now that they're both looped into the same boundary. So it would only serve a purpose for charging. I don't know. Alright, hear me out. We may have something here. All that these mowers need to do to run is to charge. Power terminals here. Also, we need our guide wire to return back to the station for charging to make it autonomous. We also need our boundary wire. I've looped the boundary wire into the backyard lawnmower. What's to say that I can't run jumper wires from the power of that charging station around the side of the house to these terminals, right? Now, in addition, the the guide wire to return back home is just one straight wire that terminates, so it's not a loop. What if I piggyback onto the other boundary wire, run it all the way along the house, then out from the bottom of this station? So either way, it's going to get a signal saying return home. Even though it's not technically hooked up to that base, it's hooked up to the other base, it's going to have the same signal saying, hey, this is how you find your home. So we've got our guide wire to return, we've got our boundary set up, now we need power. Check it out. This is the house. This is mower station 1, pre-existing. New mower station from Mr. Lightning Strike. He has his power going in. He has his guide wire going out. And of course it all takes place right back here. What I'm saying is these two copper terminals that charge that guy, I jump off them. Run it to our secondary base station. Boom. Now we have charging power at the correct voltage. And what we can do to mitigate the fact that it'll charge slowly if they're both charging at the same time, guess what? You mow at night, you mow during the day, you alternate using that juice. Next, we take our boundary wire, since it's a one wire that terminates, I'll get that same signal since they're now both programmed to that base, run it down, run it out the center. It will still have a place to park, it will still have a place to get voltage, and it will still have a straight line telling it to go back home. Now, the only problem that I foresee is the fact that this system also uses an antenna to help it find its way back home. But technically, it should know, go home, and then when it sees charge, it stops. So we won't have the redundancy of the antenna, and hopefully this one doesn't confuse that one. But I think this is worth a shot, so let's try to do a proof of concept.
One eternity later.
So things have taken a turn. What we ran into is that The system that I was talking about earlier with the diagram on the chalkboard here, of simply running the docking station and piggybacking it off of that one, would work. But the problem is that the mower itself, the robot mower, recognizes the type of signal that the boundary loop is putting out. And Husqvarna, in their grand wisdom, made sure that you could only have one mower per boundary loop. So each time that I put a mower on that boundary loop, I have to program it to the signal that it's putting out. What that does is automatically kick off the other mower. So where we're at is I started looking about getting the software for accessing the mower. It's a dealer proprietary software. They won't let anybody have it, which honestly I don't think is fair for, the right to fix your own things. Right to repair, I believe it's called. Okay, so the way around it is I have a USB connector, and there is a port down here to access the motherboard. So we started there. By we, I mean myself and ChatGPT. I'm using artificial intelligence to help me out with this a little bit. So once we accessed it, we realized that the chip on the board was still locked. It wouldn't let you go through the service port. So essentially, that port is just for things like firmware updates, for putting in customer information, etc. So what we need to do is we need to access the board directly. So this USB port is not going to do anything for me. We need to access this guy, this little test port on the board itself. So as of now, I've been testing which one is the ground, etc. I don't understand all of it, but ChatGPT does, luckily. So the AI is going to do a lot of this for me. Or not for me, but run me through it. So that's where we're at. I had to order a component called a USB to TTL serial adapter. Figure out the exact pinout of where these guys go to the chip. I'm going to be able to then connect the USB directly to the board rather than the other side here, this little service port that's just for minimal, non-invasive things. Okay, now the reason that I'm doing this is because I'm going to take the mower that is currently connected to the boundary wire, because it will only connect one mower. I'm going to steal the firmware off of this one, and the software if I have to, that is currently connected to the boundary wire, and I'm just going to clone it onto the motherboard of the other lawnmower. Meaning, this lawnmower will think it's the other lawnmower, and vice versa. There will be no identity to separate them. They will be identical, biological twins, same DNA, same everything. That way, we can have the frequency for the boundary loop on both mowers, so I can then piggyback the other docking station onto this docking station, and it's a wrap. Now, the reason why I'm going through all this effort, I could simply just buy a new power supply. I could buy a new docking station circuit board, or not circuit board, I don't sell that individually. I could buy a new docking station tower. At that point, we're spending a couple $100. Maybe that'd be easier, but where's the fun in that? Let's see if we could spend $10 on a serial TTL port, and let's see if we could hack the system. And mostly because of right to repair. Husqvarna doesn't want us to do this. Husqvarna doesn't want us to access their software. They pot their other circuit boards in resin, so we can't access those either. I feel like we should be able to repair our own things. Now, the reason that this guy is so dirty is because it's the one that's been running around in my backyard for a year. So this will also give me a good opportunity to clean it out. Anyway, that's the video, and I will have an update once I get this serial report and get ready for part 2, because we're getting in this thing.